Okay, we're going to go through this problem where this is in section 1.5 that asks you about the volume of a box. And here's a sample one. It says you've got a rectangular piece of metal. Okay, so it helps me kind of to draw that to have something to visualize. So we've got a rectangular piece of metal. It doesn't tell me the dimensions of it. That's actually what we're going to figure out, but it gives us a bunch of clues about it. It says the original piece of metal is 5 longer than it is wide. That's our clue to kind of give us a little algebra setup. So the length is 5 more than whatever the width is. So my basic unknown is that width. I'll let x be the width of the original rectangle. Then the length will be 5 more than that. So we start like that. Then the next sentence tells us we're going to cut squares that are 1 inch long from each corner. So we're going to clip out the corners from this rectangle. So clip, clip, clip. And in our example, I'm doing 1 inch. Yours may be different, but it's 1 inch in, and it's a square, so it's 1 inch all the way around, right? We're clipping these corners out. Now, whenever you clip the corners out, you could then fold this flap up, and it would make a box shape, if you can visualize that. It would be an open-topped box, sort of a bin. Now, this box then has a volume that's 374 cubic inches. From those clues, we can then figure out what x is. So we need to know the formula for the volume of a box, which is you multiply the 3 dimensions, the length times the width times the height, whatever the 3 dimensions of this box would be. So we need to first of all visualize if this were, say this was the width, this is the length, the height of the box is this is now standing up. That's how tall it is. It'll be that number right there. So the height is just a number. It's 1 in this case. Let's do the width next maybe. The width, this distance, now of the box, not of the original rectangle. So the box, we've clipped out 1 inch, we've clipped out 1 inch. So the width is that x it was, then -1, or -2. Then we've got the length. I should have left more room there, huh? The length this way, we clipped out 1 inch, we clipped out 1 inch, so we take off 1 minus 1, so it'll take off 2 inches that way. Instead of x plus 5, when we subtract our 2 inches, it'll be x plus 3. So now we got our length, width, and height represented, and the volume was given in the problem as 374, and it's in cubic inches. We don't need to write that down here in that, but that is the units that would be given. Now, in this case, since it's times 1, that's going to kind of just disappear on us. Anything times 1 will stay as is. But if you have another number in your example, say you've got a 2 or a 3, you want to divide that on each side to simplify it before you continue. So we won't have that to deal with here. So we got 374 equals x plus 3 times x minus 2. Now we've got an equation we can solve. We'll need to FOIL this together. You get x squared minus 2x plus 3x minus 6 equals 374. This is now a quadratic equation. Since we've got the x squared term, that means get it all to one side in standard form to solve it. So bring the 374 over, making it minus 374, leaving a 0 on the left side. X squared minus 2x and plus 3x becomes plus 1x, and then negative 6 and negative 374 is negative 380, right? Now, you can plug this in the formula, the quadratic formula, where a is 1, b is 1, and c is negative 380 if you like. Or you can work to unfoil it, factor it here. I really don't know right off the top of my head what multiplies to be 380. I'm thinking like 38 times 10 is 380, but that wouldn't give me a 1 in the middle. I know it's going to be x times x. I know the signs are different to get a negative last term, so I'm trying to think through different ways to multiply and get 380. So I go to my calculator and I start saying, well, 380 divided by random numbers, maybe 15. 380 divided by 17. 380 divided by 18. I'm just kind of randomly trying to find some ways to divide out 380. Oh, I found one. 20 times 19 is 380. If I do a positive 20 and a negative 19, when I FOIL it, I will get a positive 1 when I term. So that works. Once you can get this factored and equal to 0, we can use the zero factor property and set each factor equal to 0, and then solve each factor. In this case, the 20 moves across the line, I get a negative 20. In this case, I get a positive 19. So those are my two solutions for x. But because it's a reading problem, it needs to work back in the original problem too. Besides working algebraically, it needs to work in the parameters of the problem. So we can't have a negative with, so the negative answer doesn't make sense. So our winner here is 19. The question is find the original dimensions. So the original rectangle, you know, is the x before we cut its corners, x and x plus 5. So now we know x is 19 from our algebra we just solved, so the width is 19, and the length is x plus 5, or now we know 19 plus 5, which will be 24. So we would say it's a 19 by 24 original rectangle. All right, hope that helps.